Okay, right. So now we continue over here. Right. Now this one is show that the expression v equals to v naught plus at is dimensionally correct. Now we have three terms here. One term is v, which is the velocity. Then another term is v naught. We are now at this point
Yeah,
here.
yeah, yeah. Yep.
We are now here at this point here.
Mm-hmm.
Okay, so v naught is the initial velocity, a is the acceleration, and t is the time factor. So they want to check whether this formula is dimensionally correct or not. So for each of these three terms, I try to find out their dimension. Okay, so over here v is the velocity, v naught is the initial velocity, a is the acceleration, t is the time. So I take the first term v. I take the first term v. Now what is the dimension for v? L over t,
Over T.
length divided by time. What is the dimension for v naught? This one. The dimension for v naught are here. Okay, we are now here. Now this dimension for v naught is also a velocity. The dimension is also L over t.
Over T.
Then the next term is at. At. A has a dimension of L over t squared. T has a dimension of t. So when the t and t cancel, I have L over t. So if you look at all these three terms, all of them, they have the dimension L over t, L over t, L over t. So is this equation dimensionally correct?
Mm.
You see, V,
Yes.
V naught AT. V is L over T. V naught is L over T. AT is L over T.
L over T.
Yeah. So is it dimensionally correct, this equation?
Yes.
It's because they all have the same dimension. Okay. Then the next question here, right? Next question, uh, this one. They ask you true or false.
Mm-hmm.
An equation that is dimensionally correct is always physically correct up to a constant proportionality.
Okay.
What they are trying to say is, if the equation is dimensionally correct, even the proportionality constant is also correct. Is it like that?
An equation that is always physically correct.
Or it is not true. It is false because the equation may be dimensionally correct, but the constant in front of the term, okay, cannot
Mm-hmm.
cannot
Be predict
predict using the dimension,
dimension.
the proportionality constant here, the k here. We cannot know the value of k. So although the equation may be dimensionally correct, but in front of the terms there may be numbers that we don't know, right? There
Okay.
may be numbers that we don't know. So we look at this example here, the Einstein equation, the E equals to mc squared, right? Is it? No, not this is not the Einstein equation. Okay, this is not. Determine whether the equation v equals to, x equals to vt square is dimensionally correct or
Physically
not.
correct.
So what is the dimension for x? X
L.
equals to v. L, correct. What is the dimension for vt square? Vt square.
L over T times T square.
What is it?
LT.
This one.
Because you get rid of the square, so you get LT.
The t is at the bottom, t square is at
Mm-hmm.
the top. When you cancel, what you have?
L times T.
L times t. Is it the same as L?
No.
No. So is these two terms, are they dimensionally the same?
No.
No. So they are not the same, right? So
Hmm.
answer is x equals to vt square is
Not correct.
incorrect. It's not right. Okay. Now, how to get the correct one? What must you multiply to make it the same as L?
V times T.
Ah, yes, V times T. Because V times T, you will get L. So Vt is dimensionally the same as X.
X.
Correct. Very good. Any question?
No.
No, huh?